Welcome back to Precalculus. In this video, we shall explain why c squared is equal to a squared minus b squared. A, b, and c, they appear in our ellipse. A, for example, has something to do with the distance of your vertex from the center, and b has something to do with the distance of the endpoints of your minor axis from the center. But c has to do with the distance of your focus from the center. So in our definitions of the ellipse and when we laid down the standard equations, so these are the standard equations of our ellipse with vertex HK. This one has a principal axis that is horizontal. This one has a principal axis that is vertical. If you were to look back at our definition, we have this added comment. C squared is equal to a squared minus b squared, and a is greater than b. So in this video, we shall explain why this is so. Okay, so let us lay down an ellipse. Let us put that in standard position. When you say standard position, what that means is you will put it in your rectangular coordinate system. And you will do that so that you can take advantage of the rectangular coordinate system. Okay, so by using the rectangular coordinate system, we can assign coordinates to the points that lie in your ellipse, and the same with the center and focus. Okay, so this is the center, 0, 0, V1, V2, the vertices, capital B1 and B2, the endpoints of your minor axis. From V1 to V2, it's 2a. From the length of the endpoints or the length of your minor axis is 2b. And the distance from the center to one focus is c. So that is where c, a, and b will come in. Let us recall our definition of an ellipse. Again, this video is about showing why c squared is equal to a squared minus b squared. Let us recall our definition of an ellipse. If you were to locate any point in your ellipse, the sum or the combined sum of its distances from two fixed points is a constant. Okay, so in our earlier definition, we called that d. Pf1 plus Pf2 is d. Okay, Pf1 plus Pf2 is d. Okay, how about the vertex? Okay, so let us pick this vertex. This vertex lies in our ellipse. So the sum of its distance or distances from the two fixed points ought to be also equal to d. Okay, so V1F1 plus V1F2 is also equal to d. But wait a minute, look at this. V1F1 is equal in length to V2F2. So you can replace V1F1 by V2F2. So it's going to be V2F2 plus V1F2 is equal to D. Now, look at this one, V2F2 plus V1F2. So if you were to look at that, V2F2 and V1F2, that is your major axis. So in effect, your D here is 2a. It's the length of your major axis. Now that is quite a revelation, because what this means is if you were to pick any point in your ellipse, the combined sum of its distance or distances from two fixed points is equal to the length of your major axis. So let us now bring your minor axis and your focus, because that is where B and C will come in. Okay, look at this. B2 here is one endpoint of your minor axis. Okay, its distance from the center is B. That one is one focus. Its distance from the center is C. So this one is C, this is B, and the minor axis is perpendicular to the major axis. So that means this is a right triangle. Now look at this. B2 is a point in our ellipse. So that means the combined sum of its distances from two fixed points, look at this, B2F2 and B1 or B2F1 is also equal to 2a. B2F1 is equal to B2F2. Okay, so this is just the same as twice B2F1 is equal to 2A. What does that mean? That means that B2F1, B2F1 is equal to A. So these two lengths is equal to 2A, and that length is equal to A. That leads us to a right triangle. Okay, this is a right triangle whose hypotenuse has this length. It's equal to A. Its legs has lengths C and B. Okay, so pay attention to that. This is a right triangle. And so the Pythagorean formula must apply to this right triangle. The square of the hypotenuse is equal to the sum of the square of its sides. A squared is equal to C squared plus B squared. And so this is where C squared will come in. C squared is equal to A squared minus B squared.